So yeah, let's start. So the next hour is dedicated to this session, which is about building an analytics platform in Azure. Before we get started, as Kevin already said, a quick introduction of myself. Who am I? So my name is Gerhard. I'm Gerhard Brueckl. I'm working at a company called 𝐏𝐫𝐞𝐬𝐞, and we focus on building AI and analytical platforms for our customers. With the main focus on Azure. So basically all our projects that we do are in the Azure cloud. And I, for myself, am working with Microsoft data platform in general, like starting with SQL Server and then transitioning to Azure and all the data services for 15, 16 years now. And especially for the last 7 years, I'm mainly focusing on big data and cloud computing, basically. You can follow me on Twitter. You find all the contact information on the slide. I'll also present them on the last slide so that whenever you have any questions, you can just reach out to me. I'm also Microsoft MVP for data platform for a couple of years now, and do a lot of for the community, like doing sessions like this, and also for other bigger conferences like the Data Community Summit that Kevin also mentioned before. And also developing some open source tools, especially for Databricks nowadays, because I'm actually a big fan of it. So there is like a Visual Studio Code extension, also PowerShell script that you can use. So if you're using Databricks already, make sure to check them out. Besides that, I'm also a member of the PASS Austria data community, which is also organizing the SQL Saturday in Vienna. We didn't do it for the last 2 years though, or only virtually because of Corona. But yeah, we're looking forward to do another SQL Saturday next year. Yeah, so if you have any questions afterwards, as I said, like just reach out to me either on Twitter or just drop me a mail if you have any questions. Okay, but let's get into the topic. So first of all, we will discuss what does the term analytics platform actually stand for, because for everyone, it probably means something different. I'll share my view on it, and once we clarified what we're talking about, we're going to discuss why we actually want to build it on Azure or in general in the cloud, and next is to discuss all the main components that we need, and I've also prepared some real world scenarios that we did at our customers so that you get an impression what you can actually do with an analytical platform. And what steps and what processes are involved when you build it up. Okay, so what is an analytical platform? So in general, a data platform that is sourced by multiple systems. So it's kind of similar to a data warehouse, but with a much wider reach. So it's not only limited to, let's say, structural data from SQL databases, but can technically also process, let's say, non-structured or semi-structured data like logs or images, videos, whatever, and also should have ability to deal with streaming and real-time data. So that's some scenarios that are usually not covered, obviously, by a data warehouse. So the analytical platform should be able to combine all these different data sources and give you like a holistic view on across all those different streams, let's say. The analytics platform itself is built up by data engineers. Well, as I mentioned before, I also used to work in BI and data warehouse in the past, and basically transitioned to data engineering. A lot of the stuff that I used back then in data warehouse still applies in let's say in an analytical platform or in a data lake. And what we are building is actually in the end used by data analysts and data scientists. So again, like we are preparing data so it's easily consumable by data scientists and data analysts, so that, for example, they don't have to read all the log files, for example, and do the parsing and processing and pre-processing, but we as data engineers basically just prepare the data for them, that they ideally can just run a select star on a SQL table basically and get all the data without having to need to know where it's actually coming from and which pre-processing steps we already did to make the data look like they see it. Okay. So where does this whole thing come from? Why do we actually need an analytical platform? So if you consider in the past, you usually had like two completely separate streams. One was like this data warehouse or operational reporting stream, where you just had like your regular reports. Besides that, you also had other data sources like sensor or log data, which wasn't really stored because back then the data volumes that were generated were just too big to be stored, or would have been too expensive to be stored. So the only thing that you usually had is like some live reports that visualize that data, but you never had like an historic view of your sensors, for example. Okay, so that was in the very past. And yeah, the main point is that the data was not stored, and especially when it comes to data science and machine learning use cases, this historic data of those sensor values can be really valuable because you use it to train your models basically. So with the rise of big data, like another buzzword, obviously, we had at least the capabilities to store these sensor and log data. So for data warehouse and regular reports didn't really change, but we now had the ability to at least store these vast amounts of data in a data lake in HDFS back then, and use those reports for, or this data for operational reports, so that we could also see that how is, for example, a specific machine or a specific sensor behaved over time, which was not possible before because we just didn't store the historic values. And we still had the ability to use live reports because, I mean, it was ever there and well, they never change. So, and now that we had already stored all the sensor and log data that we weren't able to store before, other use cases came up with regards to advanced analytics and machine learning. So now that we have the data ready in our data lake, we want to build machine learning models to actually learn from the past and for example, like predict something that's potentially happening, like predictive maintenance. There are like tons of different use cases where the data that you now collect can now be useful. So that's like the evolution, let's say, of an analytics platform. And now we're gonna have a look on why this becoming more important and what this all has to do with the cloud. So as you can see on the slide before, it already covered a lot of different aspects and different use cases. Okay, so we still had like this data warehouse and reporting use case. We have this use case of a data lake for archiving and long time storage of the data, and we also have the machine learning use cases, right? So they're all different. They all have different requirements, all different workloads. And if you want to build something, well, build an analytics platform on premise, you require like really a lot of hardware, proper team to maintain and operate that hardware. That's just super expensive usually. And the main thing is that it's actually a huge cost investment, and you probably don't know in advance what you actually get out of it. So that's why a lot of people just didn't dare to actually run some like an analytics platform on premise. So what the cloud gives us is this flexibility and this efficiency for building this infrastructure without having a too big invest upfront, which makes it super easy to start small and grow big in the cloud. So yeah, the next part is okay. So why would we build it on Azure? So I already mentioned some of the ideas behind Azure and the availability and flexibility in terms of resources. And another big point is this separation of storage and compute. Okay, so in a traditional on-prem data platform, which was usually based on Hadoop and HDFS for the file storage, and then maybe Spark or Hive for the processing, you always had to have everything up and running all the time, which wasn't really a deal, wasn't really a big deal because well, you didn't pay for what you were using. But if your storage was growing, you had to extend. You always had to extend your cluster, and it was again very resource intensive operation, let's say. In the cloud, that's much easier because we can simply separate storage and compute. So we have like a data lake store and we have a compute, which can be Databricks or Synapse, which we'll discuss later. And you actually only pay for what you actually use. So if I provision a data lake store and only use 1 GB, then I'm only paying for that 1 GB. Even though I already know that in the next 3 years, I may grow up to 1 petabyte, I just pay for that what I'm using at the moment. If I would do the very same on premise, I could either like extend my cluster every month, which is super complex, or I start with a super big cluster up front and have all the costs associated with it without knowing if it really pays off in the end. So that's where the cloud comes in very, very handy with this start small and grow big principle. Technically, what like the core concepts or the main components that we cover in the next section could also be implemented on any cloud provider. So that's like some generic, let's say, patterns that could be applied to any cloud provider. But I choose Azure for, first of all, because I like to work with Microsoft, and that's my expertise there. But I also think that especially Azure has the best platform as a service offerings, also the best user management and integration between the different services, and also the integration between the tools and services. So that's just really easy to set up and works pretty well. I just know that for AWS, for example, it's much more hassle to get all the services talk to each other and manage users in the same way. So again, that's why I prefer Azure for this. Okay. So yeah, let's come to the main components. It's actually pretty straightforward. So that's just like a very high level overview. What you will always need, you will need some storage, obviously. You will need some processing engines, can be any. As I said, like storage and compute are themselves are independent. Those heavily interact with the storage, like reading data, doing some processing, and storing the data back in the data lake. But also providing the data to the serving layer. The serving layer can be another SQL data mart for analysis and for an API, for example, whatever. Can also be an analysis services and or an OLAP data mart, OLAP engine. But obviously, especially for the machine learning use cases, can also be Azure Machine Learning in this case, or any other let's say machine learning solution from basically any cloud vendor, because like also AWS has its own machine learning service. And the last part, it's just here for reference. We're not going to cover this. Is the consuming part, which is like one of the use cases, for example, the reporting, which is then usually done in Power BI if you're already on the Azure side. Or you can also have like some API endpoints for especially for your machine learning models, if you want to have like an item recommender in your web shop, etc. That's usually done by an API call to a model served by Azure Machine Learning Services. On top of this, there are some components that are used throughout the platform. It's the Azure Data Factory, or in general, like any scheduling and orchestration tool. And also some data cataloging and data governance tool, and in Azure that would be obviously Azure Purview, just to monitor and orchestrate everything that's happening within the platform. Okay, so for the storage, again, start small, grow big. I mentioned it before. Only pay for what you're actually using, and that's like one of the main reason why building an analytics platform in the cloud or in Azure is let's say so easy and so low effort. It's basically just like for the storage, just provisioning and data lake store, and that's it. However, you still need to consider, or should should consider some features that the storage should support. So I should be able to create folders, especially for managing your data, because it should be somehow structured, and well, you get structure with folders and subfolders and like a folder hierarchy. And also you will need to implement some kind of security concept. So that's also something that should be supported by the data lake store. Obviously, like all those features come natively with the Azure Data Lake Store. What used to be also important for a storage service was HDFS file support, so Hadoop distributed file system. But actually nowadays that's not really a big deal anymore, because HDFS is barely used, and each of the storage services, whether it's like a data lake store, a blob store, or S3, they all have their own, let's say, connectors that perform better than an HDFS endpoint would. Okay. Yeah, so that's for the storage. The next part is then the processing. As I said, like as we have this separation of storage and compute, you can basically use any, let's say any processing engine that you want. However, in Azure, it's basically either Azure Databricks or Azure Synapse Analytics. That's at least the two that I would recommend. Obviously, you could also like spin up your own Cloudera cluster or use HD Insight. But from at least from my experience, that's it's just much more overhead and much more complicated, especially in maintenance and operations. So I would definitely recommend to at least have a look at those two services, because these are the ones that you should usually use. Both of them are basically very, very flexible and scalable. So you can spin up both of them on demand. You can spin up a Databricks cluster or a Synapse SQL pool or Synapse Spark pool on demand, and then stop it once you're done with your processing. And well, obviously you only pay for the time when it's actually running. Also, there are maybe some very specific use cases that you don't know yet, where you need, for example, a very large cluster with 100+ nodes, or a very large node, like a single node, for example. But that's not a big problem in the cloud, because you can just provision a large node with 256 gigabytes or many cores for 1 hour, and then deprovision it again. You just pay for that 1 hour, and you solve your use case, and then you're happy, right? So these are like the features that that the processing engine should provide, like a scalable, flexible, and elastic cluster management. And also it should be able to process structured and unstructured data. Okay, so structured would be like a SQL-like data, and unstructured would be, maybe already JSON. JSON is some kind of semi-structured, but or usually also doesn't really play very well with SQL databases. But it can also be images or videos or whatever. Very much depends on your use case. And the key concepts are basically that the processing engine needs to scale, which is usually achieved by distributed processing, so that you have like some kind of cluster in the background that scales linear with your workload. So if you have like a workload that runs, I don't know, like 1 hour on a 4-node cluster, that if you just increase the cluster size and double it, so that the processing time goes down by half. So running the same workload then on an 8-node cluster should ideally just take like 30 minutes, for example. This fast data access part that I mentioned here in performance, it's just whenever we basically processing some data, we're actually loading it from the data lake, and this should be fast. By default, if you have like all your resources provisioned in the same, let's say, Azure region, in the same data center, then that's not a big deal, because Microsoft basically takes care of this. Just make sure that you're not that you don't have your processing engines and your data stored in different data centers. So that's just very important, because otherwise it will be very slow. In terms of capabilities and interfaces those processing engines should have, right now, a de facto standard for big data processing is Spark, which supports languages like Python, Scala, R, and also especially for the Microsoft guys, there's also a Spark.NET implementation. So nowadays you can also run C# code on a Spark cluster. So it basically just translates the C# code to Spark code. And obviously also 𝐏𝐫𝐞𝐬𝐞, which is still like the most important language, I would say, when it comes to data processing, or also for data consuming. As we are dealing with a lot of different personas, being data engineers, being data scientists, being data analysts, it's very important to have a proper security mechanism also in the processing engines. This is important for cluster management, because you don't want everyone to be able to just spin up any cluster, because then just your junior analyst goes there and spins up a 100-node cluster. That's probably not something you want. So that's why security in general is pretty important. And what's even more crucial here is the data access. So whenever you access data, it's usually through one of these processing engines, and they ideally should have their own security on the data, so that not everyone can see every data. This can either be implemented in the processing engine, but ideally that's already implemented on the data lake, and the processing engine just passes the credentials or the data through to the storage service. So now for the serving components, you will usually need to have like one service that manages all the machine learning workloads, supporting building of models, training and testing of models, and also an ability to serve those models. Serving those models is usually about creating an API service, or running batch pipelines, either on a predefined cluster or via Docker or Kubernetes. So that's very important, because that's one of the few. So Docker and Kubernetes are one of the few services that are actually flexible enough to deal with most of the workloads that come from machine learning models. And ideally, you also have some kind of model library that you can use to compare the performance of different machine learning models over time, etc. So yeah, that's for the machine learning part. Then for the general serving part, there will usually be like at least two kind of interfaces. One very obvious one, which is SQL, as most analytical tools work just fine with SQL, like Power BI or Tableau or whatever you want to use. They all support SQL, obviously. And they can also be like some specific OLAP interfaces, which are even more optimized for analytical purposes. And in the Azure environment, it would be Analysis Service and Power BI. For some other use cases, it can also be considered as serving if you just like provide, for example, a CSV file to some external partner. That's also a very, very common use case. Then when you're actually building an analytics platform that it's used to process your data and then provide the data to a third-party company, which then does some further analysis or uses the data for some marketing campaigns, whatever. Okay, so that's also a very valid use case and also considered some kind of serving. For the data management tools, we need like two of them. One of them is, or at least two of them. One is responsible for managing the different data pipelines in terms of orchestration and scheduling, so that you can define, okay, run this data pipeline at 5 a.m. every morning, and also do some proper error handling, monitoring, logging, etc., and give you the ability to define dependencies between the data pipelines. So that's just very important. And it should also be able to first of all connect natively to a lot of different data sources, so that you don't have to build like a custom connector kind of thing for each new data source. But should be flexible enough to trigger also external services using REST APIs, etc. Then the second part is the metadata store and the whole governance topic. which is actually a super complicated topic, and the only way how we can really cover it is using some proper APIs in order to let's say visualize and integrate all the data that you have in your analytics platform. And also here the connectivity and extensibility is one of the key points. Okay. Azure Purview does a really good job here, but we'll also cover some details on this later. Okay, so these now were like the, let's say, general concepts. For some of the components, I already slightly jumped into the Azure world, but consider like the last 4 or 5 slides to be like general guidance points for the components that you need to choose, or that you at least need to have in your analytics platform. Okay, so let's get started with the actual services that we want to use on Azure. So the next slides are dedicated to Azure. So when it comes to storage, you basically have the choice between using a data lake storage Gen 2 and regular blob store. So these are like the most common data stores that you will use for an analytical platform. Most of the time it will be an Azure Data Lake Store Gen 2, simply because of security and folders. But there can also be scenarios where you want to go with a blob storage, especially because of its availability and some other features that are not yet available in the Data Lake Store Gen 2, like different redundancy levels, soft delete and stuff like that. And it's usually also cheaper if you have a blob storage. Okay. So depending on the use case, let's say 95% would probably go with a Data Lake Store Gen 2, but there can also be good reasons to also use blob store. And obviously you can also use a combination for both of them. Okay. Yeah, what's next? So once you've decided which storage you actually want to use, you need to structure your storage. So opposed to this let's say theoretical idea of a data lake just being a place where you can just dump all your data and then just working magically, in reality that's not how it's working. So you always need to think of how you want to structure your data in the storage. There are a lot of different concepts out there, how you should structure your data. So if you're working with Databricks, they usually propagate this bronze, silver, gold layers in your data lake. You can also have like landing, raw, processed, refined layers, whatever they are called. It's totally up to you how you call them. There is no good or bad. What I can tell though is that you probably need at least 2, probably more like 3 different layers to build up a proper platform. One is always for input and raw data, where you just like do a one-to-one copy from the source systems. At some point, you will need to pre-process and clean the data and bring all the data sources into a common format. So, for example, if you're receiving JSON data, XML data, binary data, you want to extract the business value of this data and make it easily accessible. So you will have some pre-processing steps to just gather the data and store it in a let's say common format, being a Parquet file or Delta Lake table. That's for the pre-processed and clean part. Then you may want to have like a dedicated area for your working copies for the project that you're working on at the moment, or without interfering with any other projects and use cases. And a dedicated place where you want to store your results or your output data. So that's like the main areas, and within those main areas, you will have like further subfolders. I usually prefer to structure them by data source, then further by entity, and then the level of enrichment, like raw and preprocessed, as I mentioned before. In addition to that, you will usually have a partitioning by time. So the data lake store is just like a dump file store. It's not more nor less. And in order to be able to manage all the files that you load, it's highly recommended to also have some timely partitioning. So a dedicated folder for every year, underneath a dedicated folder for every month and for every day, and depending on the use case, maybe for every hour and maybe for every, let's say, 5 to 15 minutes also. But again, like very much depends on the use case. Yeah. Besides the stuff that I mentioned, again, there can be a lot of different scenarios which you need to reconsider how your storage is structured. If you have like multiple tenants, if you have like if you have like an API data source and where you have like usually different versions, API version 1, API version 2, and you need to deal with all the different versions. So you may also need to consider that, so that you somehow make sure that data that has the same structure is always stored in the same way, in the same folder, basically. Regarding storage and security, I mentioned before, proper security is only available in a data lake storage, where you have so-called access control lists. The main or the most important thing to know about security in a data lake store and those access control lists is that they do not inherit. So if you set your permissions on a specific data source, for example, on a folder for a specific data source, it's really only that particular folder, but not the subfolders and subfolders. So it doesn't inherit down to the subfolders. What you can do though is use so-called default permissions, which will be applied to every new item that is created under the folder or directory where the default permissions are applied. But that's a very important part actually, because this only works properly if you set up your security and your permissions before you're actually loading data. And it's also highly recommended to use Azure Active Directory groups here and do not specify any service principals or single users directly on the data lake. Because otherwise, if you want to grant a new user access and you don't have used Azure Active Directory groups, in the worst case, you have to touch, I don't know, 10 million files in your data lake just to grant a new user permissions, and that's definitely not something that you want to do. Yeah. So coming back to the different layers in the data lake. As I said, there is no clear definition what those layers should look like, but you should have a clear definition what is stored where and what is actually done between these different between the different layers. Okay, so as I said, what you usually have is a raw layer, which is a one-to-one copy. Then you have some pre-processed layer that brings everything in the common format, but does not apply any business logic yet. We like to structure the data lake in so-called projects. So a project is basically a use case that just reads a subset or a filtered subset of the pre-processed folder and then does some processing inside the project. This can be like a machine learning processing, can also be some kind of data warehouse reporting use case. And in the end, it produces some output, which can then be again consumed by other projects. If you do have requirements to export the data to external system, we also consider a so-called egress part, which is a dedicated area in the data lake that has like different permissions and where external users may get access to read that data. Okay, but as you can see here, it's pretty clear defined what stages you have, what layers you have, and what's done between those layers. Okay. And don't focus too much on how you actually want to call those layers. Okay, next part is the processing. Processing engine is one of the most important aspects of the analytics platform. As I already said, from my point of view, nowadays that's basically just two viable options in Azure, and it's either Azure Synapse Analytics with its Spark and SQL pools, or Azure Databricks. Depending on your use case, you should favor one over the other. How to put this? So from my personal experience, especially for machine learning and analytics use cases, Databricks is the better choice. If your use case is more towards data warehouse and reporting, you probably go with Azure Synapse because it has like a really good SQL engine built in there. If your use case is IoT, it again depends. I'd probably also go for Databricks, but that's also like an architectural decision, what you want to use, also in terms of so-called vendor login and other stuff. Yeah. All of them, all the processing engine like Synapse and Databricks can be started on demand. You just pay for what you use. Storage, as I mentioned, is separate, so it's just attached at runtime and you don't have to worry about that. And the only important part for the processing engine, from my point of view, is that it supports Apache Spark, because it's just like a standard. It's a standard for data engineering, for data processing, and it's more or less also becoming a standard for advanced analytics and also for machine learning. So it's just like a native choice to use a processing tool that supports Spark at some point. For the serving layer, it's usually in Azure, it should be Azure Machine Learning. However, it could also be, especially if you focus on Azure Databricks as a processing engine, it has also some of the capabilities that are listed here for the ML serving. It's also built into Databricks. If you're using Synapse, you probably want to use Azure Machine Learning. But in the end, you just need like a tool or a service that allows you to build, train, test, and operationalize your models. And for the operationalization, either like providing APIs and microservices that are usually hosted as Docker container, but also are capable to deal with streaming data and using real-time processing. So for example, like Stream Analytics that just calls like one of our microservice and gets like a fraud value for a particular transaction, for example. Also, as not all machine learning use cases are streaming or near real time, it's also very often that you just have like batch processing that does like your customer segmentation or clustering once a day or maybe once a week. So that's also something that should be natively supported by the serving, as a machine learning service component. Obviously, all the stuff that I mentioned here is supported by Azure Machine Learning, and as I said, most of it also by Azure Databricks. Yeah, the second part for the serving, especially with regards to reporting, is the SQL and the OLAP layers. What's important here, I would say that Spark per se is, from my point of view, not really designed to as a direct data source for reporting, simply because of the fact that there's always some overhead associated when you execute a query against a Spark cluster, because it's like a distributed system. It has to distribute everything. It has to collect the results back from the client, from the tribe, from the workers, and send the result back to the client. So there's always some overhead, and it will never be as fast as a regular SQL database that also has optimized indexes and everything. But the thing is that also Azure Synapse, from my experience, is not really designed for let's say too many concurrent users. So if you run a huge reporting solution with a let's say not too big amount of data, you may also consider using regular SQL database data marts for that serving layer. But depending on your requirements, especially if you also want to use an OLAP engine on top of your SQL data as the main serving layer, you can just connect directly to your Spark or Synapse pool to read the data from there once, and then continue serving it with the in-memory engines from Power BI and Azure Analysis Services. Yeah, for the data management parts, there's like just only one choice in Azure. Like for the orchestration and scheduling, it's Azure Data Factory. It's pretty good in orchestration and also doing some basic copy activities. So that's what we usually use Data Factory for. Doing the one-to-one copy from the source system to the raw layer in the data lake, and then just use it to orchestrate the execution of Databricks or Synapse notebooks. Okay. When I'm saying Data Factory here, I'm obviously also talking about Synapse pipelines, which is basically the very same as Data Factory, just natively integrated into your Synapse workspace. Yeah, for Azure Purview, especially for the whole data catalog topic and data discovery, it is really it's actually the only data cataloging tool that I know that's covering most of the requirements that usually come up when it comes to a cataloging tool. There are also some others, and also open source, for example, the Apache Atlas. However, Purview manages to create like a nice UI and very user-friendly UI on top of this, but still giving you the ability to use the Atlas APIs to add new data, to manage relationships, to manage lineage, etc. So that's actually pretty cool. And another feature of Azure Purview is that you have like lineage analysis built in. So it just analyzes your pipelines, your data factory pipelines, etc. Also your Spark pipelines, Databricks pipelines to some degree, to build up some lineage analysis across like from the source system through the data lake, through the processing pipelines, through Power BI, etc. So that's becoming better and better every day with every release. So you should definitely have a look at that if that's something that you're interested in. Yeah, so that's it for the data management, and these are like the components that you're very likely to use in different combinations if you're actually building your analytics platform in Azure. There are some additional ones that you may want to use, especially when it comes to streaming. Then at some point you will probably have event hubs and stream analytics, but I didn't cover these in the session here for now because it would just become too much. Yeah, here are just some general architectures taken from Microsoft directly that show you how this can look like and how those different components interact with each other. In this case, it's mainly focused around Azure Databricks as a processing engine. You do have the data lake store underneath that has like this bronze, silver, gold layers. As I said, that's the, let's say, the Databricks standard. But also here you see Azure Synapse Analytics on the right side for specific reporting use cases where you require a proper and high-performing SQL interface. And then again, Azure Machine Learning on top and Power BI for reporting. So that's these services are set in the serving layer actually. Okay, and yeah, at the bottom you see all these monitoring and governance services that you can use in addition. We covered Azure Purview, the other ones, Azure DevOps for CI/CD and the source control and project management, Azure Key Vaults for secure storage of your sensitive values, Azure Active Directory for the user management, Azure Monitor for monitoring all the different services that you're using. Yeah, so that's just like one sample architecture that you can use around Azure Databricks. If you have like a Synapse, if you're focusing on Synapse, it's looking slightly different. You also have like some Synapse pipelines that do your processing, store the data in the data lake store, and then again you have like Synapse Spark pools and for the machine learning use cases also, and then Synapse SQL pools again for the serving and analysis services in Power BI for the actual reporting then. Okay, so any questions so far? Because the next part I would cover, I know that I'm really jumping through the slides here because it's a lot of content. So if there are any questions.
There actually is one question.
Yep.
I think you actually covered this a little bit back, so forgive me for not jumping in there. But what is the advantage of having server containers in a storage ADLS to organize the data versus having everything in a single container?
Okay. Yeah, good question. So there's actually two ways how you can secure your data in a data lake store. I mentioned the access control lists. So if you store your data in a data lake store, you can use those access control lists on the file and on the folder level. And the other option how you can secure your data is so-called role-based access. Okay. However, role-based access can only be applied on the container level. So you can have like a role that has like real access, a read access on the whole container. That's the advantage of using role-based access is that it doesn't suffer of this inheritance problems of access control lists. So you can just simply add a new user to this Azure role using the role-based access control. And it doesn't need to inherit down the permissions to each and every file. Okay, so it makes the user management much easier if you only need to secure your data on the, let's say on one level, and this one level is then your containers. So for example, you create a container for raw data, you recreate a container for refined data, and you create a container for processed data. Then you can very easily add a new user and grant it this new user read permissions on the process container, for example, without having to touch access control lists. But as I said, it's basically limited to one level. Okay.
Perfect.
So that's how I would distinguish it. Yeah. So it's not as flexible, but it's easier to maintain.
And
if you use containers. Yep.
Perfect. And the only other question we have, is there any performance differences between SQL Server versus SQL dedicated pool in Synapse versus SQL in Power BI Data Mart? And which one is the best for Power BI Direct Query? Or is that just a little 3-hour explanation?
Yeah, that's a tough question. Well, I can try to give you an answer. There are some limitations when it comes to Azure Synapse SQL pools. Again, as it is an MPP architecture, like also a cluster architecture behind it, and especially for the resource management, it's a bit more complicated there, and it can happen very easily that, especially if you have a lot of concurrent users, that the users keep blocking each other. However, if your data volumes are in the terabytes or even petabytes, and you need to have a SQL engine, and then I guess Synapse is your only choice. For the rest, whether you use, I think also SQL Power BI Data Marts use Azure SQL database in the background, so there should be little to no difference if just use and manage the Azure SQL database on your own. It's just that if you manage it on your own, you're probably more flexible when you need to scale it up. Honestly, I don't know what's behind. I mean, what let's say SKU or scale level is behind a Power BI Data Mart. Yeah, so I can't really give you a clear answer on that question. Yeah,
it's all good. It's all good. And that's all the questions we have right now. So,
okay, cool. We only have couple of minutes left. I would have some more slides about some real world use cases, what we did there.
So actually, Gerhard, we have about 15 minutes. If you want
to. True. It's not 1 hour. It's 1 hour 15, right? Okay. Yeah, then I'll just continue. I don't know if you had any Q&A or anything planned, but if we already covered like those 2 questions, then I would just continue with the real world examples. That's fine.
Yeah, go ahead. I think that'll be perfect.
Okay. Okay, so these are some scenarios that we implemented over the last years for our customers. I'll go through, well, probably not all of them, or at least the first one and probably the second or the third one. But let me just get started and we see how it goes with the time. Okay, so custom analytics. So the goal of the project was to build an analytics platform that allows you to track a customer across all its different touch points across the services that the company provides, and basically creating like a 360-degree profile around the customer. So just to give you a little example, so that customer has like a web shop, it obviously has a web page, it has like a newsletter system, it has some advertising banners on other websites, and yeah, Google Analytics for some website tracking, etc. And they basically like created a unique token for each customer based on its email address actually. This one was then stored as a cookie, and so you could basically like combine those different sources into and link them to one, let's say, golden record of a customer. Okay. So you basically had like all the information for that one customer, which allowed him to build really good AI and machine learning models with regards to targeting the customers with additional newsletter send outs, but also about advertisements in the web shop or on third-party sites, so that you know that when, for example, that particular customer has been in a web shop already and was looking for a particular product a couple of times, then chances are good that he's very interested in that particular product. And if you send him like an advertisement again, then at some point may he click it and may he buy it. Okay, so that's like one of the use cases, besides some others. So we did have a lot of different data sources. Some were just APIs, some came from a SQL database, some were, as I said, like web logs, as it says here, which had like more than 1,000 columns. It's also not like easy to process by a regular database. And we also had some constraints in terms of how fresh the data should be. So we needed to have like hourly data, like every hour we basically like load new data from all the source systems. Yeah, so this was like the scenario, and what we used is mainly data factory pipelines and Databricks to load all the data sources, especially for the REST APIs. We use Databricks notebooks because Data Factory does provide some REST API capabilities, but not as flexible as we needed them to be. The web logs were basically just CSV files or tab-separated files. We could just download them from the web service. CRM and other SQL databases were just copy activities in the data factory. And also the web shop was basically like a SQL database. So we used these 2 tools to, first of all, get all the raw data, and all the other transformation steps, we also use Databricks notebooks. Okay. So especially for the REST APIs and for the web logs, we use Databricks to extract all the valuable information, because out of those like 1,000 plus columns in the web logs, we were actually only interested in 150, I think, according to the customer's definition. So then we use Databricks, which gave us like a really nice first of all, really good performance with also larger volumes of data, but also the flexibility to process same structured data. Like all the REST APIs are basically JSON results, and the weblogs, as I said, like this huge and very wide table of logs. The SQL part and WebShop part was pretty straightforward. And once we had all the data loaded in our preprocessed and refined layers, we could finally start with our use cases. For example, the segmentation. So that was like a daily job running that did the customer segmentation. So whether like this customer is a young customer that's easy to convince to buy a new product, or it's like an older customer that probably needs more time to convince. And based on these segments and then clusters of customers, they were basically controlling the send out of newsletters. So who is actually receiving which newsletter. Also in terms of calculating a chance or a ratio of how big a chance is if I send that particular customer another newsletter, how big is the chance that he actually unsubscribes because he feels spammed with this additional newsletter. So this was one use case, and the other one is in the web shop. That's like the example that I briefly mentioned before, to give like each customer individual next best offer. So well, based on the activities that we know the customer did from the other touch points. I don't know, like weblogs, if he browsed for that particular product on another site. So that you just know, okay, which products interest the customer the most, and we give him like we present him that product because he's very, very likely to buy it compared to any other products. So that was that use case. For storage, obviously we used Data Lake Store, processing as the Databricks notebooks, data factory pipelines. In this particular use case, we did not use any cataloging service. Also, it's some while back, and the Azure Purview wasn't there at that time. We also had some reporting use cases there. We simply used Power BI, which was sourced by SQL tables in Azure Databricks that worked pretty well, because the reports were only refreshed once, and once the data was in the in-memory engine of Power BI, we didn't have to have the Databricks clusters running, because every query could simply be answered by the in-memory engine. Okay. The next, let me check what the time actually is. I guess we can cover all three. The next scenario is providing like an analytics platform for a data science team, which was analyzing driver behavior of users. So they developed an app. It was an insurance company. They developed an app that you can install on your mobile device, and whenever you're driving with your car, you just start the app, or it actually starts automatically, and it tracks your behavior. So whether you're like a fast driver, an aggressive driver, or more like a passive driver, and based on that behavior and the maneuvers that you do, they were basically calculating your insurance level and the amount of money that you need to pay like for each month. So if you know that you are like a safe driver and you don't go fast very often, you can opt into that service and say, okay, hey, I'm using the app, and you know that I'm driving safely, so please give me like a lower rate for like a lower monthly rate. Okay. So everything was solely built in Azure. So it was everything from the data collections using IoT Hub, the whole streaming, the data processing, etc., was purely built on Azure. In the end, we had like 100,000 devices constantly growing. For the so one of the main challenges actually was the was to map a driver or a car on the road. So you just get like the GPS points, and you need to know whether he's like driving in an urban area, whether he's driving on a highway, etc. And also get the speed limit, for example, or special road signs that are in that area, or yeah, in that area where he's currently driving. So I don't like whether he's like speeding in front of his school, for example, which is probably not a good thing for your overall score. And to get all this information, we basically took the GPS points and basically enriched them with here maps. So Nokia here, it's a map provider that gives you all this information about like where you are, what the road signs are, etc. Yeah, so that was pretty interesting and actually very complex. But again, this was done in Databricks, and Databricks was did give us like the flexibility that we needed to actually do this here maps enrichment and everything. Yeah. So that was the scenario that we wanted to cover. The challenging parts here were that the data that we used was actually delivered by the IoT platform, which was basically like an event hub capture. So they were like sending the data to IoT Hub and Event Hub. And we did not use the stream capabilities of Event Hub, but we used so-called Event Hub capture. So there's like a feature of Event Hub that just stores and dumps the data on a storage account every, let's say, 5 minutes. And then we just process these data. This data there is like Avro files, which contain the actual message. The message itself was a nested JSON that was compressed using zlib and message pack. So it's not so easy to unpack that message and process all this nested JSON, but that's where Spark and Databricks really shines, because that was actually quite easy once we knew how to do it. We also had different versions and schemas coming from the IoT platform, because the IoT platform was also constantly growing and evolving. Even though we had this data delivered in the event hub capture every 5 minutes, we just did actual processing of the data every hour. Simply because those systems usually work much better with batch processing than they do with streaming, especially if you have a lot of updates. So that was the main reason here. And then for the most complex part is this here enrichment. We only did it on a daily basis, because it's easier to send a huge batch in once than sending small batches every minute, for example. Yeah. So I said, like we use Databricks. It's very flexible and scalable, and we provided the data to the data scientists in Azure SQL tables, and the data scientists were also using Azure Databricks. So that was like a real benefit, that they actually used the very same platform that the data engineers used, that prepared the data for them. So there was like no change in the actual processing system between data engineering and data science, which can really make the life a lot easier for both parties. Okay. So like this data science use case was one of the use cases. So that the data scientists could basically use this historic data that was accumulated over the years, and with the GPS data, etc., to basically build and train the data science models and machine learning models. Okay. The second part is that there was also some reporting requirements. So the insurance wanted to know, okay, how many customers they actually have that use the app, how they distribute across demographic attributes and groups, Yeah, so we also use this data to source a Power BI report, which was then displayed in a dedicated portal for that customer. And as I said before, like as a base for data scientists. So these were the two use cases that we covered there. Yeah, that's another one that's now more on modern data warehouse and signups. So the use case here was that we have like an online booking system that's online 24/7. It was an airline in this case. It was like a 500 gigabyte database, like this booking system, but it only contained like the last 18 months, and then the data was cleaned again because otherwise the database would grow too big, and this everything that was older than 18 months was archived, but was not easily accessible anymore. So once we moved all this whole solution to the cloud, we could just load all the data, and we didn't have any constraints anymore about historic data. We could just load everything and have everything available and ready in one place. Again, in terms of data sources, besides the SQL, this booking system, we also had some other APIs and JSON data sources. And we need to make sure that we have like a reporting system that's decoupled from the live system. So because we obviously not want to slow down the online booking system if we do any of our processing. So again, we extract all the data, basically rebuild the data model basically we rebuilt most of the data model that was in the online booking system, rebuilt it again in the analytics platform, and then allowed the users to run reports on the full history. For that, we used Azure Analysis Services and Power BI, and the Analysis Services cube on its own was already like 100 or 70 gigabytes, I think. So it was quite big, and it actually performed pretty well. Okay. Yeah. In order to get all the data from the source system, we always used delta loads. So based on a created on or modified flag. And we built up like some kind of framework that allowed us to use, well, first of all, we have like a signups pipeline that basically copy the raw data into a data lake. And then we had a set of stored procedures. It's kind of a framework that dynamically created external tables for us based on some metadata, and then allowed us to process those into a Synapse SQL pool. Okay. Yeah, and as I said, like it was like a framework and very much metadata driven. So if we needed to add like a new table to our load, we could just modify some of our configuration tables, add that new table, and it would just be loaded automatically with our processing pipelines. Yeah. As this use case was very SQL heavy, and the customer had very good SSIS developers, we actually used also integration services within Azure Data Factory to do some SQL processing. Because especially when it comes to pure, let's say pure SQL transformations, I think integration services is still a very viable option. And we used to run it in a virtual machine here. And yeah, I think these are the three most important use cases that we covered here. It should just give you like an idea of what you can do with an analytical platform, and which use cases you can cover. And yeah, I don't want to go into data screening too much because I think it's pretty obvious. At some point, you need to load the data that you want to screen, do some pre-processing. Whether you do it in Databricks or Synapse, it doesn't really matter. see how and if you can use the data, if you can combine it with other data that you have already loaded, and then just analyze it for some further insights. Yeah, it's not really related. I mean, it is related to the analytics platform, especially for the ability to see whether you can use new data in combination with existing data. But it's not like this heavy processing that you usually have an analytics platform for. Okay, so what are some key takeaways for when you're actually building an analytics platform in Azure? I think the most important part is planning your storage really well in advance, knowing how you want to structure it, which layers you need, which folder structure you need, etc., which security you need. Because if that changes during the projects, this can cause a lot of troubles because you probably have to change all your processing pipelines. And also you probably have to move or reprocess all the data. And that's usually the most expensive part, like the processing and reprocessing of data. So that's something that you should try to avoid. So you'd rather spend some more time in designing your storage before you actually load any data. Also, what you should have learned from the session that an analytical platform can serve many different use cases. The most obvious ones are data warehousing and reporting use cases, but as I said, like also for advanced analytics and machine learning, can also be used for streaming use cases, etc. So the use cases are actually endless. So because you have like the key point is that you have all the data in one place, that it's easily accessible, and then it's totally up to you what you're actually doing with the data. In terms of selecting the services, there's actually just one point that you should consider, and I think that applies to every good architecture. So you shouldn't use too many different services. The services that we mentioned before are the ones that I would recommend that you should use. Don't mix it too much. I mean, there can be use cases where you have maybe Databricks and Synapse, but if there is no good reason, I'd highly recommend to just stick to one of them, because each additional technology makes the whole architecture and design much more complicated. And also, especially like as we are in the cloud, definitely go with platform as a service services if possible, because you just don't have to worry about the whole maintenance and whole maintenance and operation stuff for the platform services. Okay. Yeah, and that's it. So that was my session on building an analytics platform in Azure. Again, if you have any questions, either ask them now, or as I said, you can also contact me anytime via my email or on my Twitter account.
So there's no additional queries or questions that we can go through. But while we're waiting to see if there's any more questions, I'll actually do the raffle for today. So I'll take over the screen here for just a second.
Gerhard, quick one. This is Ravi here. You mentioned that the platform is white labeled or something like that. So could you elaborate a little bit more on what that is about?
Oh yeah, so let me go back to that. Yeah, I didn't go into detail on this, I know, because I didn't think it's important. Okay, so that was for this one. Okay, so as I said, like that was for an insurance company, and they actually built a solution so that they can also sell it to other insurance companies as a white label solution, meaning that the other insurance that would use the same solution would just be able to like change the logo, change the name of the app, whatever, but in the background use the very same resources. And what I wanted to highlight here, didn't actually mention because it wasn't too important, is that for that solution, we also built like a huge CI/CD pipeline in Azure DevOps that basically allowed us to spin up a whole new environment with all different components, with more or less a, yeah, like let's say like 30 minutes in Azure DevOps. Okay. And that's the white labeled part here. So also we didn't only have like dev test prods there, but we had like different test environment and also different production environments. So in total we had 7 or 8 environments for our internal testing. And as I said, if you would have needed an 8th or a 9th environment, we could very easily do it, because everything, like the whole infrastructure and all parts of the solution were basically packed into infrastructure as code that could be deployed with Azure DevOps.
That entire solution can be deployed within 30 minutes for any other people also, if they are interested. That's what you're saying. Okay.
Yeah. Exactly.
Within their own cloud or on premise, or that is?
No, it's tied to Azure. I mean, it was like a pure Azure solution. So it's obviously only working on Azure. So if you would have wanted to host it you could easily have hosted it in your own Azure subscription, basically.
Okay, fantastic. Thanks a lot.
Okay, cool.